everybody, it's us again. I'm Emily.
And I'm Maggie, and we work for Salem Sound Coast Watch. You've probably seen us in your classroom before, or maybe on one of the other videos we've put together this year.
We're here today to talk to you a little bit more about erosion and to help you think about and design different ways to prevent erosion and protect our shorelines.
The different solutions that engineers may use depend on many factors, such as how developed the area is, how many people live there, what the shoreline looks like and is made of, or what the height above water is. For example, if the shoreline is low-lying and already has some salt marsh, then making the salt marsh larger could work to absorb wave energy and prevent erosion. That would be an example of soft stabilization. Or, if there are buildings right up to the water's edge, then a seawall might be the best option. And that would be an example of coastal armoring. So let's dig into the three different solution types.
The first method we want to show you is coastal armoring. Coastal armoring is using hard materials to protect the shoreline from erosion. Some examples of armoring include building seawalls, floodgates, riprap, or jetties. Sometimes there are unintended consequences to armoring, like increased wave energy. Bouncing off the hard surfaces, and erosion might still occur where you don't expect it.
Here, you see large stones called riprap being used to keep sediment in place where the bank has been reconstructed. Riprap will help prevent erosion which is otherwise caused by the rushing river and lots of stormwater draining off the land during heavy rainfall. Culverts like these along the North River help direct water where we want it to go, making the stream banks strong enough to hold moving vehicles and also a moving stream below.
Solid walls like this one are used to stabilize the land at the water's edge, protecting homes, parks, or in this case, an important roadway from flooding and intense waves. The shape of this seawall is intended to redirect the water back away from the road. Sometimes storms are so strong that waves still crash over the wall.
Another armoring example is the formation of rock jetties, like this one at Independence Park in Beverly. This rock structure slows down incoming waves and prevents sand and rocks from moving too far along the beach.
The second solution type is soft stabilization. Soft stabilization techniques create natural barriers along the coast. These living shorelines are able to slow the force of wave energy and absorb floodwaters, unlike hardened shorelines, which can sometimes increase wave energy. Can you think of other benefits to these solutions?
This roadside rain garden was planted to help slow down and filter the stormwater pollution that was running off the street directly into the river. This rain garden on Commercial Street is equipped with curb cuts that direct the stormwater flow right into the garden. The roots of all the native plants in the garden help to keep sediment in place and also filter the incoming water. All rain gardens are specially built with layers of mulch, gravel, other filtering material, and rain collection tanks that hold onto the stormwater and slowly clean it, preventing pollution from entering the river. This particular rain garden is next to a brackish, which means kind of salty, tidal river. At high tide, the garden captures that tidal water and prevents flooding in the streets.
Here at Collins Cove, Salem Sound Coast Watch recently planted a salt marsh or living shoreline. The neighborhood here is heavily residential and has historical importance to Salem. The cove experiences intense flooding along the bike walking path during the highest tides and even more so during storms. The plants and sediment in the living shoreline now help to absorb some of that floodwater and to slow down the energy of the waves, which will reduce how much erosion or sediment is moved around. There are other erosion control methods at Collins Cove, which include a riprap bank, shown here at the edge of the living shoreline, along with a cement seawall around the beach and park area.
The third solution type is living with water. In many cases, we need to get creative in how we adapt to climate change. Living with water is accepting and adapting to frequent flooding events. Adaptation methods include elevating homes, designing floodable parks, and even floating buildings. Can you think of any other creative solutions?
This new building, located in a coastal marina, is equipped with flood louvers. These louvers act like gates or valves that will let seawater in and out, in the event that the building is inundated with water during a large storm or extremely high tide. Sometimes it is better for the water to be allowed in, which reduces the pressure on the building structure.
This is a brand new apartment building in Salem, right on the North River. This section of the river is tidally affected, which means that it experiences high and low tides, just like at a beach closer to the ocean. In the event that the North River floods and overflows the riverbanks, the bottom floor of this building could be flooded. To avoid damage to any property, the first floor of this building is exclusively parking. Made entirely of concrete, the floodwater can safely enter and exit this level of the building without causing any damage. This small pond catches rainwater that is flowing off of the roof into the gutters and directs it to the garden before flowing straight to the river. The water would eventually exit the pond and flow underground through a natural filtration system, which would include stones, rocks, and even tree roots.
In some cases, people are getting very creative with the fact that sea level will rise. This restaurant in Norway gives diners a real immersive experience.
An alternative to living with water is called managed retreat, and it includes strategically relocating buildings and people in anticipation of coastal hazards. After being pummeled by Hurricane Sandy in 2012, this neighborhood on Staten Island in New York went through a managed retreat. Knowing that flooding events would become regular and the chances of another major hurricane were likely, it was the best option. You can see in these satellite images that from 2014 to 2018, the homes were removed. The government bought the homes, tore them down, and nature was able to reclaim the land.
Now you've learned about many different types of solutions and have seen some erosion engineering up close. Now it's time for you to create your own unique solution. What methods and materials will you use to protect your shoreline?
Good luck, engineers! Be creative and have fun!